Okay, so for the sake of making it incredibly boring, Marinho, I think we should just make a type here. Yeah, make a type that you're gonna call CLI, and that's gonna aggregate. That's gonna be a record that's gonna aggregate every single configuration we're gonna in the future allow the person to change via the CLI arguments. And then in the main, we just mock like something that has a DB in there, and then we just go from there because I can do the real CLI stuff later. That's just boring work. What do you say?
That's probably okay.
So T equals. Okay, so let's put CLI. Whoops. So the first thing we probably should do is Sakura module name, and that's gonna be it's gonna be a string, right? And for now we're only gonna have that. And then in here we're gonna say CLI equals um, something along the lines of probably um, where is that? Oh, I did open lib in there, so I can just do something like compiler type CLI, and then we're gonna say Sakura module name equals db in, something like that, and we're gonna pass that to here as an argument. I'm gonna pass that to there. So let's do a done build and see how this shit breaks. So the function executor compile blah blah blah. Okay, so it worked. Now we need to change the executor. So compile, let compile. That's, yeah, it is this one. So we're gonna call this a config, which is gonna be compiler types CLI. Uh, then after having that here, we need to pass that. Who we need to pass that to, money? Actually, are we gonna do it in the preprocessor? The thing
No, we actually need a pass before the preprocessor.
before? Why?
Actually, that's not quite it. Because here's the thing: we need to parse all of the Sakura files.
Why?
Well, we're gonna need to parse them at some point,
No,
right?
we're gonna have to parse them, but why can't we just make the executor go through the list of these things, find the ones that end with this extension, and literally like dummy dumb concatenate them, the contents of the file? Like, am I tripping?
That's gonna mess up the source information when we parse it.
No, no, no. I mean, yes, we're gonna still use the original files for the real compilation of things. Uh,
We can't do that though, because we need to
I see.
treat yeah, because we need to treat all of the Sakura files together as a single module. So we can't actually just use the original files because they are separate.
Okay, but okay, continue with your suggestion. What would you do?
So after parsing the Sakura files, but before pre-processing them, we just concatenate them because they are lists of clauses, right? Well, they are actually finger trees, but
Doesn't matter. Doesn't really matter.
if they are not finger trees, they should be because now we need to concatenate them. So
Uh, what is the output of the parser? It is a list. Okay, so do you want to change that to be a finger tree on the level of the return type of this function? Or can we just grab the list, convert to a finger tree, concat, and then turn it back
It's
into a
better
list?
it's better to change the parser because then we avoid having to traverse this thing repeatedly and keep converting it to different types.
Okay, I'm not gonna do that. To do change output type of this to be a finger tree. Okay, what else?
Well, after we have the concatenated Sakura module,
Oh wait,
we
before
need
you continue, I should also, I'm gonna forget, sorry. I should also put a to do here. Make Sakura module name as an available CLI option with DB being the default. Okay, go back, continue. Sorry.
well, after we concatenate everything together, we need to we need to turn that into a fake module, which we I think we will have to. Well, first of all, we need to run the preprocessor, right? Because we haven't done that at this point yet. But then the output of that needs to be needs to be.
We have it in here. Well, everything you said is this line, right? Oops.
Hmm,
We just don't.
yeah,
We are not just treating the Sakura stuff specially, and I think now we should.
yeah. We should.
Okay, so that means what is this? Oh, this is a finger tree of clauses, though. Interesting. So, oh, but this is a bat map of the preprocessed stuff. Of the preprocessed stuff. Okay, so probably we can. Wait a moment. This is returning a finger tree of clauses, and so this is the key, and this is the map. Okay, so do you want to add another accumulator thing in here? Maybe? What do you think?
Another accumulator.
Yeah, because
Preprocess
yeah, this is the
one.
function we use for the fold, right? So we are folding things, and at some point we're gonna call preproc one. So preproc one. Yeah, and we're using this in a fold as expected. And in here, we are actually saving things as we go through. Should we save the list of clauses like in a gigantic like bat finger tree
No,
empty?
no, no, no. We need to treat this as if it was just another module that we're compiling. So we don't need to change the
Save
accumulator, I don't think.
module as we are compiling.
We may need to change. Hmm. We're passing the list of file paths as the final arguments to the fold. Yeah, we're gonna have to remove the Sakura files from that list at some point as well.
What is the type of preprocessed files? Is a thing from a file to a list of clauses. No, man, can't we just use this? Like we can know ahead of we already know we can do that. We have all of the files. It's already everything is preprocessed. We just need to do something. We already have the clauses with the source information parsed and preprocessed. Can't we just like split this map between the keys that are Sakura file paths and the ones that are not?
No, man, we need to change. We need to treat all of the Sakura files as if they were a single file. We can't just throw them into the normal pipeline as they are.
I don't understand. Let me rephrase the question. Do you agree that every single Sakura file will be parsed and preprocessed in here with the correct source location for error reporting?
We need to do the concatenation between the parsing and the preprocessing is the issue.
Between.
Yeah. Because the pre-processing is where we make the dependency graph, right?
Uh,
So the Karuta files that depend on Sakura stuff will depend on the concatenated module, not on the individual files.
okay, so we do need to split this file paths list into the Sakura ones and the non-Sakura ones.
Yeah, we do.
Okay. Okay, so let's try to go into batteries and see if there is a function that does that. Like a filter that is more convenient, because I don't want to do the double filters, right? So batteries. So bat list there. So is there any function that does a filter but also gives me the ones that doesn't fulfill the filter? That would be very handy right now. Uh, we can always also implement that ourselves because why not? But hey, it would be very cool and convenient.
Do you
Option.
not want a partition, if I heard that right?
It's yeah, it is partition actually. Yeah, thank you, too. It is partition actually. So let's say Sakura files, and let's also say known Sakura files. I'm gonna make this just Karuta files because there's not really. Oh, there's the prologue stuff, but we're not gonna care for that right now. So we're gonna do that. So you do um, bat list partition, and then there comes a function and a bunch of file paths, and then in. So now what we need to do is a function here, and the function is essentially um, okay. We use this here as well. We grab the extension and then we check if it is or not. So because of that, I'm going to make a separate function. So is Sakura file, which receives a file path. And then we're going to do file name extension file path equals this in. And then we can just put that in here, like so. And then in here, we don't need the extension for anything else, most probably, so we can just nuke that. And we can just say is Sakura file path. And then this can also go away. Okay, we have them both separately, Marin. Then, what do we do?
Well, then we need to, before we handle all the Karuta files as we currently do, we need to parse all of the Sakura files. We need to concatenate the parsed files before we pre-process them.
Okay, so
Um,
let's say Sakura module. Mm, Sakura clauses, right? Because that's the output of the parser. So this is going to be probably a list fold, probably left, and then there's a function, and then we have the accumulator, which is going to be an empty list in this case, and then we have the list of stuff, which is going to be the Sakura files. And then you said we parse them, and we concatenate them. This is the result of the parsing. Cool. So that's going to be, let's now here do that. So parsed uh, file path, and then we do. Oh, I guess we can just do right revert this and do. Oh, but the parsing can fail, right? What's the type? The parsing is an attempt. Parsing is an attempt. That is interesting. Now let's actually keep the left then because we're just gonna use concat instead of cons. Um, okay, so we do parse file path, bind, which we don't have, then concat that with the parsed stuff, essentially. So we are using error. So error bind. What's the type? You receive a function that does that. You're using this down there, right? So yeah, result bind. So this grabs a result, then grabs a function and returns the end result. Um, we need something like that. So result, this has parentheses, and then I need a function. So I'm gonna grab the file. Yeah, I'm gonna grab the file path parsed, and I'm gonna do that concat with the thing. So I think it's append, right? And then later we can just change this to finger trees, and I know it's gonna be like non-performant and stuff. So file path parsed with parsed. And that should be kinda it in a sense. The problem is that this fold is not monadic, right? So the types will not line up.
I mean, I just wrote some cursed code. I'm using a reference of an OK of an option. Like, what am I doing?
A reference of an okay of an option.
Like, I was just doing it and doing type Tetris, right? And then I just saw, and then what am I doing? And then I have to stop now.
Yeah, you should stop that. Wait a moment. This receives accumulator, the thing, and it needs to return the new accumulator. Ah, it's because this needs to be an
By the
oh.
way, Magita, about your question, I was writing, but I think it's easier to say.
Mhm.
I don't know about GPU handling, but SBCL by itself should have a reasonably good code generator, and it has good primitives if we want to do stuff like SIMD and assembly primitives and controlling memory allocation.
Yeah, I
So
know it's a very good compiler and it's very optimized, right? But I think you need to know where to optimize, and that's the pitfall.
well, out of the box, if you can annotate things and types and stuff like that, it should generate reasonably good code without much poking around. But if we need to poke around, it also has good primitives for that.
Mhm. So I think I will write a tiny VM in Common Lisp just to test, and then I'll let you know, and then I just throw that at you, and you become the owner of that. Well, how about that?
Uh,
Uh, that sounds good to me, I guess.
Okay, that's it then. That sounds good to me. That was a bit reluctant.
oh yeah, of course. That was very
By
funny.
the way, uh, let me see if I can find it. I don't know if you heard about the April APL implementation, but
Hmm.
I
Yeah,
think
Uh,
I've heard
they
about
have
it. But
a
I haven't.
bunch of let's see if I
ah,
can find it. They
Maria,
have
help me
vector
here.
primitives
I'm too
using
tired to think
CMD
straight.
in SBCL if you want example.
Do you want to go to the other call, Devo? Like, just to not intervene
Sure.
with the guys talking. Let's go there.
Uh,
Okay, Lemos, what's up?
so I want to make a fold m, which is essentially a function that allows us to do the monadic stuff. I'm just gonna call this fold. So what should be the types in here? So this should be an f. Yeah, it should be just this, right? This should be it. That's my understanding. But what should be the type in here? That's kind of the thing. It needs to receive The accumulator needs to be that. Yeah, it needs to be that, right? So list, and then there's a B. We need to return a B here, actually. B. Like, I'm trying to make something more convenient because I think it's already time to have a fold for the attempts, and it's pissing the shit out of me. It's pissing the shit out of me. So actually, this is correct. We have a list, an attempt of a list. No, this is this correct, or am I tripping?
Elements, name list attempt.
Yeah, and we want this to return this, right? That's what we want. That's what we actually want. Yeah, you have a B list attempt and then an A, and then you need to return a new one of those. Yeah, I think that's it actually. So this is the accumulator for sure. This is the accumulator. Then you need to do that and you need to return a new attempt like that. Something along those lines, I believe. Something along those lines. Do you agree?
Is that correct?
Here it is. The values element has type that, but an expression is expected to be that. It's not an attempt according to the thing. Oh, of course it's not an attempt because that doesn't make sense. I'm just tripping. The list is just a pure list, right? There we go. Ah, finally.
Yeah.
Okay, now that we have that, we can finally just go here and say fuck that. Fold, and we will just. But that's still not that convenient, right? Because I can remove this from here, but I still have to do the unwrapping of the accumulator myself, right? We need to implement
Yeah.
the F a little bit more carefully, actually. Something like this. So that means that you're gonna have an ACC here, an element, and then we're gonna do something like match the ACC with, and if it is a none, if it is an error, we just return that. So I just say, actually it's easier to just do the OK first. So if it's an OK, then you're gonna have an ACC, and we can do shadowing here just fine. And then we pass the ACC and the element to this function. Otherwise, we're gonna have an error, and then we just return the error. How can we improve this to be a little bit more pretty? Okay, are you ready? Are you ready to make it pretty?
I think
Result
so.
map, um, and then this is fun flip f element ACC. Isn't that it?
I'm not sure if that's how result map works in OCaml.
Okay, so what are you expecting here? No, it is, right? We have a function, a pure function. Yeah, it is definitely it definitely should be how that works, but what is the flip doing here? You receive a B. Yeah, I think it should be something along these lines. But it's not compiling, so let's see why. This expression has type. Ah. Wait, what? It has a result with an attempt inside. Ah, it's because the f is actually generating an effect, right?
Yeah, f is monadic.
Okay, do we want to have f to be pure? That's the question. Or do we want it to keep it as with an effect?
We want f to be parsed when we actually use this thing, right?
Yes.
Then it needs to be effectful, no?
Yeah, I guess it does, right? I guess it does. I mean, really, it doesn't really need to. So let's actually piss off the OCaml people even more. Let's call this, let's remove the effect from this one. Let's just keep it as it is right there. No, but then, no, this doesn't make sense. It needs to be the other way around. Because you want this error here to propagate, right? So that's the reason. So let's actually go back to what it was. Yeah, let's actually go back to what it was. Okay, so do you have any ideas to improve on this one?
Uh, I mean, you can use a function, like not a fun, but actually a function. You know, the one that better matches on its single argument.
Yeah, no, but are you telling me that there are no functions that can do the job?
uh, I mean, there should be. There's result fold, which might be useful. I think
Wait, it
maybe.
is bind. No, it is bind. I was just tripping. It is what I said, but instead of map, it needs to be bind. It needs to, it's exactly what I wrote, I think. F element ACC. Am I tripping again? Like, I'm very tired now. I am tripping again. So what are the arguments here? Oh, the result comes first. Sure. There. I may be tripping, but I can always do some Haskell, man. It's fun. Um, and the funny thing is that you can do flip again on the bind to remove the lambda, but I think that's a little bit unnecessary, right? Do you see what I'm saying?
Yeah.
You can do even
That.
more, like, make it even more cursed, but that's not going to bother. Okay, so that means now that we have this function, that we just need to implement the f. F needs to be a function that takes the list and an accumulator and the thing, which now means that, yeah, isn't this it? Like, am I tripping? List append. Ah, this needs to be monadic, right? So this needs to be um, error, okay, like that. Done. Whew, I'm tired as fuck. Uh, for the sake of the recording, I am stupid, but now I have two jobs, so I'm more tired usually. For the next little bit. Okay, so we have the Sakura clauses, and we have concatenated the outputs of those things. So what do we do now?
Uh, we need to pass. Well, we need to do.
Wait a moment. Um, let's just make our lives a little bit easier here, because come on. Let's make this a let star, and let's just remove this nonsense there, and the nonsense here can also go away. Okay, go. This is much better, right?
Yeah. Okay. So we need to. We need to pass this to the preprocessor now as the first thing that we preprocess because Sakura stuff can only depend on other Sakura stuff and we just concatenated all of that, so this shouldn't depend on anything at all. So it's safe to preprocess this first.
Okay, what's the thing? Oh, it needs to receive a list of clauses. Perfect. So that means we can just pipe this. How convenient. So it's pre. Ah, but we need a preprocessor, and we don't have a preprocessor at this point.
We're going to create one because this is the beginning of the preprocessor pipeline.
Okay, wait a moment. So where is our preprocessor coming from? Preprocessor. Let preprocessor. Oh, it's inside the preprocess1 function. So that's a problem. Okay, so how do you want to initialize it? This particular preprocessor.
It's inside of the preprocess one.
Yeah, which makes sense, right? Because every single time we have
We
a file path, we need to
we
initialize the
can just
preprocessor.
we can just initialize it.
No, but we need a file path.
We need to create one. Actually, we don't need to create one. We can just say, well, we need to use a fake file path at this point because we need to, like, this is going to determine the module name among other things.
Oh, but that's
And
a
the module
problem,
name
right?
needs to, no, this is a fake file.
Yeah, but how can we gonna generate a fake file that is guaranteed to be like?
We don't need to generate an actual file though.
We don't need to generate a file. No, I'm not talking about that. We need to make a file name that is impossible to conflict with a real one.
We need to base it on the we need to base it on the name of the module.
Okay, so let's do that. Well, in that case, we can just do the thing that I was doing. So here we're going to just call preprocessor initialize, which is going to be the Sakura module name. Like this.
.skr. Do we need a .skr actually?
Why not?
I guess it's fine.
So then this is a Sakura, what this returns? Oops. It returns an output. So this is a Sakura output. Okay, so the type of this is that. There we go. What do we do now?
Uh, at some point down there, we end up initializing some dependencies, like when we call the depend the
Yeah,
when you do the
it's in
fold
here.
over all the
Yeah, it's in
Karuta
here.
files, right?
Yeah, it's in here.
Yeah, we should use the dependencies that came out of pre-processing the Sakura files instead of an empty one.
Clever. Sakura output dependencies. Fancy. I like it. Then we do what? We should probably change this, right? So this should be Karuta files.
Mm, this should be.
This is the sorting. This is the topological sorting, right? You have the expanded graph and you have the files. Before we were doing all the files. But now all the Sakura files are like pre-processed. So is there a point in putting the something else aside from Karuta files in here?
I don't think so. What do we do when we compile? Compile all sorted file paths. But we need to compile the Sakura module as well, though.
Yeah, but we have pre-processed files, right? So where is this coming from? That's the question. Ah, this is coming from. Oh, we are also using the entire thing in here.
Ah, the matmap string empty also needs to be the. We need to grab the external. I think we do. Let's see, clauses.
No, there's only two things in there: dependencies and thingies. We don't have a batmap thing. We can actually go to the preprocessor to confirm that. So output. Yeah, we only have two things in here, as you can see.
Dependencies and clauses. What are we doing with the clauses after we preprocess each file?
After we preprocess the files, what do we do with the clauses? That's your question.
Add
We
file
pass
path.
them to here probably to compile one file, and then in here
No. This is called in a fold. How do we do that fold actually? That's the better question.
There's no. We are doing via recursion. I remember that. Let me actually go back. Yeah. So this is a compile all function that is essentially doing the fold via the sorted files, and we use. Yeah. And this can also be improved. So let me do that real quick, Styles. Yeah, bind without being an operator is very annoying in OCaml. So you should actually probably not use that. There we go. Anyway, we just compile one file with the preprocessed files, and the preprocessed files have the clauses inside. Because we have this thing, remember? This is where the clauses go to.
No. Okay, that's the type. But where are we actually constructing this thing?
Inside preprocess one. Let's go. Yeah, it's in here. Oops.
Okay. So we add file path clauses preprocess. We need to change the initial. We need to change the initial accumulator for this thing as well, because right now we're using an empty map, but we need to use a map that includes the Sakura module.
Yeah. Is there a function that does that in batmap? A singleton or something?
There might be, but I'm not sure.
Batmap. Um, okay, so singleton, yes, there is. Awesome. So singleton. Then we need to pass a name for it, which probably means we
It
should
needs to
make
be
them.
the module. Actually, is this the file name or the module name?
This is the file name. 100% file name.
So we need to use the fake file name that we created, I
Yeah.
guess.
Which I'm gonna grab from here. Sakura file name. There. It's saying that there is a problem. I'm gonna check this later. Let's finish what we're doing here. Okay, here it is. So Sakura file name, and you said we need the clauses, so that's gonna be Sakura output clauses. There we go. So what are you mad about? There you go. This expression has type attempt. Ah, I'm so glad I made shit like this.
Hmm.
Okay. Okay, it worked. What else?
Uh,
This is bind, right? Yeah, this is definitely bind. Which means we can probably get nuke. Let's use that a little more, man, because I keep doing bad stuff. Ah, but this is in opposite order, and is using a record thing. Yeah, okay, that's a bad place to do that. Let's see what are we doing over here. Yeah, over here. Does the order of the append matters?
uh,
It shouldn't, right?
this is for the Sakura output. Yeah, it shouldn't.
Yeah, so this we can just do that list append file uh, parsed, and then we also just say error okay, and then all of this becomes that and that. It's not happy about that. Ah, okay. This actually needs to be like this. Right? No? Wait a moment though.
No, it was right before. You just needed to, like,
Like
that
this?
double pipe should be just a normal.
Like this?
Actually, no, that's wrong.
No, I think it
Parse
needs to
file
be
path.
this because bind is expecting to receive a function that returns a result. You see what I'm saying?
But list append doesn't return a result, Lemos. This needs to be like
Yeah, we need to do error okay here and put parentheses there and there. There we go. Not so bad, in my opinion. Not so bad. We probably should have an operator that actually does this for us. This portion. And then you can just pass a pure function.
hmm.
Something like which symbol do you prefer?
Or you could use result map as well. That's an option.
Result map. Actually, that's better. Wait.
That's a normal pipe now, not a bind.
Perfect. Thank you, Marin. Thank you, thank you, thank you. And then, yeah, no, it needs to be like this. It needs to be like this. And then down here, the problem is that we need to access the field of this record, right? And there are no functions in OCaml to do that as far as I understand. So let's keep it like this for now. That's fine. That's actually completely fine. Okay, so what else? We have it. We have made the single unified Sakura, right?
Yes, we can pre-process it,
Do we have to change
and
the lookup now then? Or
yeah,
we did
now we
the...
need to.
Wait, go
Yeah,
on.
no, now we need to actually do the Sakura lookup and then the actual Sakura compiler.
No, but that's the thing. Isn't now that we have a single unified module, virtual module, isn't the lookup rules just the same as the normal ones? Or am I going nuts now?
Mm, isn't the lookup rules the same? Well,
Because if it is, we did a bunch of we made the compiler a functor maybe for no reason. No, there was a reason, right? We needed this. The compilation is very different. So this was not worthless. But the lookup module being an argument, maybe it's unnecessary. What rules are different now that we have a single Sakura module? They being together makes them global. So,
hmm.
am I wrong?
uh, I guess technically we don't. We may not need a separate lookup for Sakura then. Do we?
Well, think carefully about that because then I can just nuke the module, the lookup module being an argument, right? Because right now we are using the same just for the sake of making it compile. But the question is there? Oh, there is. Damn. Okay, I found one. If when compiling a Sakura module, you exhaust the file, we should not try to look into other files.
Oh, that is very true, actually.
Because we're not going to allow you to use Karuta functions inside of the Sakura module, at least for now.
That is very true.
So, which is inconvenient, right? Because maybe you do have a function in the Karuta world that would be useful to manipulating the data in the Sakura world, and you're going to have to copy paste. And that sucks. But
I mean, only if you want to actually store it in the database.
wait, what do you mean by that?
Just unless you want to store the relation in the actual database, then it can just be a Karuta relation that you call on the program.
It cannot be, because everything that you're doing in a Sakura file, inside of the Sakura directives, everything will be stored, right? Everything. So if you have a function, well, a predicate, that you're using in the definition of a relation, for example, in a persisted relation, and you're using some auxiliary stuff, that reference needs to be somewhere in the disk. So as soon as you use it, you have to save it.
Oh yeah, no. If you want to use it from inside of Sakura schema, like inside of a predicate that you're defining for Sakura, then yeah, you do need to actually store it on the database, regardless.
Yeah, but we're not gonna allow you to do otherwise. Like everything that you're gonna do in a Sakura file, let's actually open one just for the sake of explaining things. So everything you do in a wait, I don't have the file that you I don't know where I saved it. Okay, anyway, it doesn't matter. We know that we're gonna have modules inside the Sakura file. And the reason for that is because that's going to allow us to do the same signature checking and things like that. In the future, we may even have functors. But inside of a module struct in a Sakura file, you won't be able to define anything that is not inside of another directive, right?
Yeah, no. Inside of a Sakura file, everything that you put there is going in the database and is usable from well, from other definitions in Sakura, I guess.
Exactly. So that means that implies, I guess, that you're not going to be able to call from an external module a Karuta predicate, right?
Yeah, you should not have access to anything from Karuta because if you have something that's in a Karuta module that's not stored in the database, so it should not be accessible inside of a Sakura definition because it's referring to something that does not exist from the
Well,
point of view of the database.
I guess in a very far future we could implement a flavor of dynamic linking that would allow that to be possible. But right now that seems like a stretch, right? You agree on that?
Yeah, I agree.
Okay, so that means that there is a difference, which means that this was not for nothing. Cool. Let's actually, okay, so database, we need to have a lookup implementation. So lookup ML. For now, I'm going to copy this. And there we have it. And then in here, executor, instead of compiler, it's going to be database. And then I do build. And it is complaining about stuff. Ah, I know why. Because this is using the types from... Yeah, it's very fucked up. This is using the types from the compiler. This is using the types of the compiler, Marinho. Now what?
Uh, 1 second. I think. Let's see. Uh,
What does the signature says? Look up. You need to have a type T. Yeah, we are fucked. Because here's the thing. Our type T is the compiler in the case of the compiler, right? We don't have an equivalent of that for Sakura.
why not?
Because compiling Sakura uses uses the well, it uses the compiler actually. So maybe what we should do is just compiler.types. But I don't know if that's a thing. Did you mean type? Unbound module types. Um, let well, we need to do this open, but I also need to have the binding. So let's do let open compiler Uh, types. No, that's not it. I want to rename it. How do you rename it in OCaml? Do you just do this? Module types equals
If you're opening
compiler.
compiler types, don't you already have like the T there already?
I do have, but there was a problem. Well, we can try. Yeah, you see? Cyclic. So you need.
You don't need. I'm pretty sure you don't need to do that though. The type T equals T.
Oh, so you mean like this should be a thing? I don't think that's gonna work. Open types. Okay. Types dot, right? There we go. Um,
Hmm.
yeah, the type T is required but not provided. You
I
couldn't
think
do
you need
it.
to I think you need to include the module instead of just opening it.
Include compiler types. Like this?
Yeah, but then I don't think you need to open because you're already including it.
Okay, let's do the same here. So let's replace a string. Let's replace types dot with nothing. And then include. Perfect. Okay, so now let's make the lookup understanding of this thing. So here's the funny thing. Doing what I said is essentially making the ancestors of the compiler dumber, isn't it?
Yeah, you need to.
You need to copy paste the code that we had before, isn't it?
The code that we had before.
Yeah, before we did this thing that we are looking at, we had that exact problem, right?
Yeah, that's basically what we need to do.
But at the time it was a problem. Right now it's the solution, which is poetic. Compiler. Okay, so ancestors of the compiler. Here it is. I have it. We can just copy paste that. Boom. Is that it? Everything else is the same?
Hmm. I'm pretty sure you can just include the other lookup and then and then rebind ancestors of the compiler.
Oh, rebind it. Okay. Wait, but this is also an opportunity. We can improve the error messages for Sakura. What do you say?
I mean, we can.
Let's see if there's any messages that we should change. Okay, so undefined qualifier. That seems okay. Qualifiers reference signature instead of a module. That also seems okay. Undefined in current scope. This can be improved. Undefined in the scope of Sakura files. What do you say?
Mm, I think that's okay.
Found a module instead of a signature. Module defined it here. Same thing. Yeah, but it's only one message. I don't think that's worth it.
Well, you can just like instead of copy pasting everything, you can just include the other lookup and define ancestors of the compiler, like override the definition locally.
Yeah, that's what I'm gonna do. Everything is the same aside from this, which is funny and poetic. So in here, we're gonna say include compiler lookup, and we're gonna rebind that. Perfect. Does that compile? It does. It does compile. Crazy, man. Crazy. That was easy. Okay.
Do you actually need to include the compiler types? Because that's already included in the lookup, right?
I think you do. That's not how this works. I think. Let's see. Oh, it is how that works. So it is like in C. These include here. And the chain keeps up. Cool. Okay, so, man, are we there? No, we cannot be there, right? Because where's my roadmap, my proposal?
We need to actually emit the code now. We have the lookup rule and we have the module
Oh, yeah. But let's do a
concatenated.
commit. Let's do a commit. Okay. Okay, so let's see. We have main. We have. Wait, we have bind twice. Why? No, that's wrong. Thank you. So we have that. We have that.
Hello, Lucas.
Yeah, I didn't notice. Hello, Lucas.
Hello.
Okay, so we made a fold for error type for the attempt type. Then we actually implemented global understanding of Sakura stuff because the scoping is global for those. I had some to-dos, and we changed that, and we changed that, and we also have some untracked files. Okay, so let's actually push commit. Make Sakura files a unified module with global scoping. Cool. Okay, now we need to generate the code, right? So let's actually go into sakura.ml. Sakura.ml. And what we're gonna do is, okay, what do you want to do first, Marinho? I guess that's the question, right? Do you want to do directives or declarations first? Because the declarations are here, but they are like useless.
Uh, I guess let's do declarations first.
Okay.
Actually, can we? Can we?
I have another question though, because my understanding, like, are we not gonna need anything that is like exclusive to Sakura inside of the compiler? We're using the same compiler for both. Is that okay?
Mm,
I guess it should be
it
okay.
it may or may not be okay depending on how we decide to do it because we do need some information for bookkeeping that's specific to Sakura.
Like what?
Like whether a predicate is stored or not. Like not stored. It's if it's what was the word we were using?
Persisted?
Persisted. Yes.
No, but I don't think that's a problem. You know why? Because when we're gonna pass ourselves to the directive compilation. Actually, we are already doing that. We are passing step. So we're gonna go here anyway. Ah, wait. No, it is what I said, right? So when we actually, like, inside of the directive, let's actually go there, just for the sake of explaining things better. So when we go to the persisted, right? So persisted, we're actually gonna call the step, and we're gonna get the output of that, and then that's gonna be probably a fresh compiler, and then we can extract everything we need and continue doing whatever we're doing. So the bookkeeping is gonna be handled inside of this scope. No?
That doesn't quite work because we're going to say, okay, there is a. Actually, I forgot how are we going to do this? Are we going to do like persisted and then whatever we put inside of that, like all the declarations have to be there?
Yes.
Okay, well, in that case, yeah, this works already. So actually, does that mean we actually shouldn't have declarations outside of directives?
But that's what I said 40 minutes ago. Every time you are in a Sakura file, your module struct cannot have any declaration implementation outside of a directive. That actually, I said that as a question before.
Yeah, I think that's correct. And then the directives will have to be responsible for actually adding the predicate bindings and emitting the predicate codes,
Yeah, but
but
I
then
think I
that
found a
means
problem. I think I found a problem with
what?
what I said. After, because like, imagine that you have an ephemeral. Oh, ephemeral is a bad one. A constraint, right? We're not gonna allow you to use a constraint inside of Karuta, the predicate the definition and the application layer. Constraints are exclusive to be sent to Sakura as predicates. That means that we need to be able to differentiate between a
Well,
predicate that is inside this directive than from those ones.
well, the directive handler will have to deal with that, no?
No. But that's outside of here. That's the problem. Because let's say you have true predicates in persisted, true in ephemeral, and true in constraint. When we get out of here and we start compiling the Karuta stuff, Karuta will try to use some persisted and ephemeral, for example. But if he tries to do use
Mm,
to the constraint, we need to say, no, you cannot do that.
well, we can just not export the constraints when we build the module.
We can only not export the constraints when we build the module.
Like, we already have a mechanism for that. Remember when we were doing signatures, you can hide some definitions?
Ah. Well, the error message will be bad, right? Because if you leverage the system that we already made for signatures, it's not gonna say the real reason you cannot do it. Because the real reason is because it is inside of a constraint directive. It's not because it's hidden. You see?
Well, from the outside, it is like if you ignore for a second that this module is implemented by the Sakura compiler. Um, from the outside, yeah, the reason is because this is actually hidden. This is not exposed
No.
to
I am
users
no.
of the module.
Technically, it is correct what you're saying. I'm just saying that we could do better. Like in terms of user experience, you have something hidden. That's true. But can we report more to make the debugging process or the fixing of that error faster? And in my view, we can, because we can be more precise about what is hidden. At least we should try to. Maybe in the beginning, because we are trying to leverage everything we built before, we can just do what you said, which is this is undefined or whatever, and the error message is going to be not as good as it could be. And then in the future, we can do something about it. What do you think?
Yeah, that's probably okay.
Um, there's something bothering me. Uh, if ah okay, there is a problem. Um, the understanding of a signature is not the same as it is in Karuta. You know why?
But we're not actually gonna use signatures.
We will.
Why?
Okay, that's the thing. So originally, when I had a conversation with Mageta wanted to use the module in the signature system inside of a Sakura context because then you can tell the Karuta portion what's going to be available, right? Because maybe Mageta was probably imagining some internal definitions that you want to hide, that you want to be exclusive to Sakura, and it's not going to be exported. And you can use the mechanism that we already implemented to do that. Right now, we are proposing a new mechanism, which is to understand which directive the predicate is in, and then make it hidden automatically or not. So now we don't have a purpose for signatures really. You see?
Well, you can't really define a signature inside of. Actually, can you?
You
Inside of
can.
Sakura.
Of course you can. It's going to be parsed, it's going to be preprocessed, it's fine. What I was originally thinking is that signatures would be only be able to export things that are persistent or ephemeral. But that means we cannot use the normal signature compilation for this directive in a Sakura context. Because here we are
Why
doing
not?
that. Because this has well, if we go with what I am saying, this is special because it needs to check if whatever is being written in the signature is actually persistent or ephemeral.
Why?
Because you should not be able to export to the outside world something that is marked as a constraint.
Why?
Because of what I just said 10 minutes ago. We
No,
said
no, 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 no,
we
no.
said 10 minutes ago.
I don't know. You are confusing the signature, the boundary between Karuta and Sakura with the usage of signatures within Sakura. Those are two different things, okay? You cannot. I agree, it makes no sense to export a constraint from Sakura to Karuta. But if you have a signature that's defined inside of a Sakura context, why should you not be able to export a constraint from that signature
You're exporting to who?
to somewhere else inside of Sakura?
Oh, so you're talking about like nested modules then.
Well, if we decide to allow that, because remember, everything is global, so that may not necessarily be a thing.
No, I think it should be a thing because if you have a module A inside of a Sakura file and it has a function, let's actually type that down. Uh, so
Actually, that's an interesting point. Maybe Sakura file should be able to import Karuta signatures, because signatures don't exist at runtime anyways, right?
well, but then we are making a promise, and that's my problem. That's why I compare to dynamic linking.
But it's not dynamic because signatures are compile time only.
No. It is dynamic because at some point we are allowing the compilation to proceed because we are assuming that at runtime that's going to be available, right?
But signatures don't exist at runtime anyways.
No, but the signature, even though we do the checks at compile time, right? It is still and it still creates an expectation at runtime, don't you think?
We don't.
No. Okay. Um, okay, so we are saying
A signature is basically a type lemos.
no. Forget. I'm not. That's the confusion we are having here. I'm not disagreeing with what you're saying. I'm just saying that from what I understand from a signature is that yes, we check them only at runtime and they only exist at
No, no, no,
compile.
no,
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 at compile
no, no,
time.
no.
Sorry.
We check.
We check them
Yeah,
at
we check
compile
a.
time and they only exist at compile time. But the reason that the man, that's hard to put into words. The reason that they matter is because they are making an assertion of what will happen at runtime.
They are making an assertion about which bindings will be exported by a module.
Exactly, but that those bindings will exist. Agree?
They will,
Exactly.
and they will exist for Sakura as well. So what's
Exactly.
the problem?
No. I'm not saying that's a problem. I'm just saying that even those signatures are only checked at compile time, and they only exist at compile time, they make an assertion about something that will happen at runtime.
That's the whole point. What's the
Exactly.
problem?
Exactly. And then and that's why I did the comparison because Sakura, from the perspective of Karuta, is an external thing. So we are making a promise if we allow signatures to be a thing in Sakura that whatever we are saying exists will exist.
How is that any difference from enforcing a constraint at compile time?
Because differently than differently than in what we did for modules and in the compiler, that Sakura is understood as a third party in a sense.
So what? The semantics match? Shouldn't we make the constructs play nicely with each other?
Okay, so we are gonna allow you to make a promise to Sakura in that sense.
Well,
That
we're
this
making a
rule
promise
exists.
to we're making a promise to the Sakura part of the compiler. We're not necessarily going to send that to the database.
Wait, but then I'm confused. So you are referencing a signature that exists at the application layer, but we're not gonna send that to the disk?
I mean, if Sakura is going to have some mechanism, actually, that's a question. Will Sakura have some mechanism to like hide some bindings outside of a scope of whatever?
In our side or on their side?
On their side?
Probably not, but we should ask. But I imagine the answer is no, because there's really no point in doing that, I think. Like, what could they make? Well, what could be written in Karuta that after being persisted would make sense to not be available afterwards? It's
Not
weird.
not be available at all, just not be available outside of it.
Yeah, exactly. But what could Sakura do with that?
Well, they could
Like,
add lets.
well, like that's essentially making a secret trigger in a sense. That's weird.
No, not a secret trigger. It's actually how can I say it? It's you can use it to make local bindings effectively.
Local, no, yeah, local bindings. I agree, but local bindings that are written in Karuta, sent to Sakura, and not gonna be available at all anymore. Like, I'm having a hard time imagining a situation where I would want that. So I wrote it in Karuta, but because the signature says so, it's not gonna be exported after being registered in the disk. What would be the use case of that?
That's why I asked if there are plans to have something like a module on the Sakura side with hidden stuff.
Well, Mageto was thinking about it, but he couldn't. Like, I don't. I think I myself pushed him to like not think about that right now because we are already working on making it global. Because the reason he wanted to think about is because that the things being global, like in schemas being global, like in Postgres, makes it fundamentally different on how modules work, the scoping rules work, as you know it, right? It's global, that's why we concatenated it, that's why we have to create an artificial module name and things like that. Um, Mageto wanted to try to implement modules so we can be consistent on both sides, but I told him to not focus on that. So I don't know if we're ever going to have modules in the Sakura side. I don't even know how that would look like.
Well, if we're not gonna have modules on the Sakura side, then I don't see why Sakura should handle signatures at all in that case,
Well,
even locally.
like I said, um, the reason is because originally, where is it? Here, prologue mode. The reason is that in the beginning we thought, Nageta thought, that you can use the scoping, the availability rules, like the hidden definitions or not, of the signatures to the outside world. And the reason that he probably thought that is because he was imagining we would have known Sakura. Either we would have known Sakura things in the Sakura file, or, or for some random reason, you don't want to export a particular relation. Is that a good use case? You don't want to export a particular relation.
Hmm. I mean, if you want to hide the fact that a particular relation exists,
Of
like
course you. No, wait. Could you remind me again how our import directive works like this, right? You do db here, and then everything's going to be prefixed with db.
yeah, That is
Wait,
correct.
wait, wait. There is a problem that we were short-sighted. Every Sakura file is a schema. That means that concatenating them together cannot be done.
Every Sakura file is a schema. What do you mean?
If you, I think even in our deal I said that. I can check it out later. Remember the reason we created Sakura files in the first place is because Magetta was thinking on having this directive, and this directive would work as a wrapper of both signatures and modules inside of a file. But
Right,
because
so
the
then,
yeah, but because the scoping is so weird of this thing, I was very bothered by it, and you suggested, okay, if we don't want to make something on the level of directives, let's go even further. And then we created a file for it.
yeah,
But that um, first of all, we cannot just concatenate the shit. That doesn't work.
why not? Why not?
Because we need to keep the intermediate level of the schema.
Why?
Because when you're using it, you're going to be doing db schema relation.
Why? What is a schema from Sakura's perspective?
Schema from Sakura's perspective is a namespace.
Which is just a prefix for the name, right?
Which is just, well, it is a qualifier for the name.
And it is global, right?
And it is global.
So why does concatenating them matter?
Because if you grab the contents of multiple schemas and they have the same relation name, you're going to have a problem.
Well, you don't really have to make the concatenation itself a schema.
I don't follow.
Like, you could just say, okay, a Sakura file may have like schemas inside of it, and the schema is basically just a
No, 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 no,
namespacing
no.
segment.
No. That's the confusion. The file name is the schema.
The file name is the schema. Well, in
Yeah,
that case, before concatenating, then we just need to wrap the contents inside of a schema directive.
exactly.
What's the
No, there's no problem with that, but we need to change that, agree? That's not how that currently works. That's the first.
That's assuming that we want actually to tie the file name to the schema definition itself. Do we
But
actually want that? That
that
sounds like a bad idea to me.
that sounds like that was the original proposal of Sakura files. That was the entire reason they exist.
No, the reason they exist is because the scoping rules are wonky
No,
between
that
Sakura
was
and
not no,
Karuta.
that was not the reason we created them. I agree that after we identified that after we got the news that the scoping would be global, it became handy. It came in handy because then we have a very convenient way of doing the global stuff. But that was not the original reason at all. The original reason was because we had Magetta proposed the existence of this directive, and the example was user. This is even in the original file that I sent to you with our brainstorm, this thing. But because the scoping rules were so different via a directive, it got confusing to me. Because imagine that this was a Karuta file. How would it work if you do qualified like Karuta module, then you would do schema, so user, but the scoping of this is one thing and the scoping of this is another thing, and I complain about that.
Yeah.
Then it came the idea of like, okay, let's actually make the schema the file. That's why it has a different extension for it. Because originally we wouldn't have different files. Everything would be Karuta.
Yeah, I do remember that.
Yes, and then again, I agreed that making the thing global after we decided to come up with a different file came in handy. But now we are back to the original question, because now you're thinking
No,
it's a bad idea.
that's backwards, Lemus. The thing was global to begin with, and that's what was bothering us, and that's why we decided
No, no,
to
no. It
split it
was
off.
not that was bothering me. I remember pretty clearly that the thing that was bothering me is how this directive was interfering with the qualification of predicates.
Interfering with the qualification of predicates.
Yeah, because if you have something like this, you think everything is a module. Hence, the scoping rules apply to all of them. But this thing in the middle is not a module.
Yeah, pulling schemas into separate files doesn't actually fix that, though.
No. Then wait, it didn't fix. No, it fixed it because you cannot have this anymore if this is a Sakura file.
It doesn't, because if you have user colon whatever, right?
Sure.
It still looks like a normal module reference, but it isn't.
No. Then we went to this solution, and I made a message for that, and I proposed changing to this. And then you said, let's do it this.
I think you're skipping a step somewhere in that line of thought, Lemus.
No, that's the timeline of the messages that I can. Well, I remember our conversations, and we do have the messages in the records. But if I'm skipping one step, which one I'm skipping?
Why we made the files separate in the first place?
My complaint, maybe yours was different at the time, but my complaint was that I didn't want this directive to exist at all.
And why did you not want that directive?
Because when used in combination with modules, shit gets weird.
Yes, because of the scoping rules, right? They get messed up.
Yeah, that's the first. But there is also something unsettling about having a signature inside this. Because having a signature in a module, because you are kind of like, wait, what does it mean to? Oh, it means that now these things are global, but what is the purpose of a signature then? And all those questions popped up in my head. And I didn't want, again, this is not a module, it doesn't have a signature, and this is just for the sake of namespacing because the Sakura has schemas. And because of such confusion, when you propose to have a different file, it would solve that problem to me. And maybe to you, the purpose of having a separate file is mainly because of the scoping being weird. Which I agree. It makes it weird because when you look like this, right? When you do this, like the scoping, understanding what is the scoping is very difficult and uncomfortable. So what I thought would happen is that we would make Sakura files be the schemas.
Yeah, I think that's a bad idea. Because then part of the schema definition is not in any file whatsoever, it's in a file name.
Yeah, which the schema only matters for the namespacing.
But that's wrong because the name itself is going to be stored in the database, no? Which means now you can no longer rename your files.
Well, I like that. I like the file being the schema. But I understand your complaint. You're pretty like namespacing being only buckets. I think that's such a simple use case that being on the file name is fine.
I think that's terrible because then the organization of your files is now tied to the organization of the data in the database in a way
Not the
that.
organization of the files, just the names of them.
Well, yes, just the names of them.
Just the names of them. Okay, so we can either do the following. We can either keep the original idea that I had, which you're not a fan, or we can do something else. Maybe bring back the schema directive.
I think it's fine to bring back the schema directive because, like,
That's gonna be so
We know
terrible to read. But
why.
okay. Because I don't know immediately by looking at it and knowing ML modules how they interact. It's terrible to me. But okay. So what you want to do is essentially this and keeping this thing.
I mean, you don't necessarily have to put a schema between the DB and the relation.
I think you must because
Why?
I don't think Magenta will allow us to have public schemas, which means that
Public schemas.
which
What
means that
even is a
every
schema?
relation will be in a schema. Every relation.
What even is a schema, Lemos?
Bucket with a name.
No, no, no. I mean, inside of Sakura, what even is a schema?
In their runtime, I have no idea. Probably something that matters for scoping and lookups.
Ask Magetta. He's right there on the other channel.
Okay,
Or someone in here.
let's assume that it is for scope and lookups. What then?
I don't think we should assume that, actually.
Well, it's the assumption that makes the most sense. That's why how we use it in Postgres.
You have another assumption baked into there that you're not recognizing. You're assuming that schemas even exist in the first place as
I
a
know they
formal thing.
exist. No, I know that. No, I'm not saying they are formal at all. I'm saying I'm replicating what Magetta said. Sakura has schemas and they work like Postgres schemas. That's it. I'm not saying there's any formality in that. I'm just replicating the information.
I still think we should double check with Magetta because, like, things over on Sakura side are changing very quickly.
No, we can ask him. That's not a problem. I agree we should ask. But I just want to do the mental experiment with you because I'm 95% sure that's the case.
Well, in that case, we should do the following. Okay, we
Yes.
will have a schema directive. You will not be allowed to define the same schema twice. I think it's a bad idea to have the implementation of a schema spread over multiple files. So that's forbidden.
Oh, but the files are already unique. Oh man, that's so annoying.
No, no, no. But the file name is not part of the schema name. That's the important part.
No. I understand you are unbinding those things, but that constraint was already fulfilled by the file system. But okay. Okay, continue. Then
Uh, and then,
are you going to be able to have
well,
modules instead of that? Signatures?
I don't see why not.
Yeah. Yeah, I disagree fundamentally with that, but you are the designer, so I'm gonna go with it.
Well, if a schema is just a like a namespacing thing, it's literally just a prefix that you add to the name. Why would you not be able to put a module inside of a schema? If we have, assuming Sakura will have modules at all, right? Which it may not have.
It won't have, well, in the foreseeable future, it won't have modules. Okay, let's actually go through that. What will Magetta do? What will Sakura do? 95% certainty on me on that one. It's essentially gonna look. There's gonna be Sakura persisted here, and then we're gonna have something like the prologue mode is getting tough. Anyway, so what will Magetta do? He needs to receive which schema it is, and he needs to know which relation needs to be persisted by, not being ephemeral, not a view. That's it. Everything else, modules and signature, that's completely not relevant to Sakura at all. That's just for us. That's just for the understanding of the programmer interacting with Sakura from our side. That's the only thing that
Uh,
matters.
in that case, do we actually need the schema directive at all? Can't we just use modules?
Then we go back to the scoping problem.
No, we don't, because this is a Sakura module, not a Karuta module. It can have different semantics.
Using the same syntax and words. And in the same type of file.
Well, it's not in the same type of file.
No. Well, agree. It's not in this case. It's not in the same type of file. So you would make the module exactly like this, but
Mm,
wait, you said keeping this, but having or not having the schema directive again?
Because like, if you have a schema, which is basically a namespace, then what's the difference between a schema and a module?
Well, it depends on the question. How can we leverage? Are we going to leverage your signatures or not? Which is the beginning of the conversation. And what I think Magetta meant is that you would be able to export and hide some stuff using the signature semantics that we made. Right? So
Well,
SIGB and that. And then we even
well, we
came
can.
up with this thing about putting the types here as well, right?
Well, yeah. But like, even if Sakura doesn't support signatures, we can support it on our side, like
Yeah,
unilaterally.
yeah, but that's the thing. If having signatures only makes sense if you're able to hide stuff. Agree?
Well, we control the scoping inside of the compiler, so we can hide stuff.
Now, yeah, but we know that everything needs to be inside of a Sakura thing, a Sakura directive, and everything in Sakura directives will be stored. So then we go back to the original question of like,
Well, not necessarily. If a signature doesn't exist in Sakura as a runtime thing, then it doesn't make sense to store something that's compile time only.
oh wait, so you're proposing that things that are being exported in a signature will not be saved?
No, I'm proposing that the signature itself will not be saved.
No. But nobody was proposing that. Nobody. I'm trying to understand. What I'm trying to explain is that signatures matter if you want to hide some stuff and be explicit what you want to show provide. But in a Sakura context, everything is going to be provided because everything is going to be saved.
Well, just because everything's going to be saved, it doesn't mean everything will be accessible by the user of the Sakura module.
Essentially like a private method in Java or something.
Uh, kinda, I guess.
So the proposal would be, let me think a little bit. So you're gonna have a schema directive, you will have a signature and a module inside those things. The file is gonna keep being Sakura, but now only the extension matters. You're gonna be able to have multiple schemas in a single file, and signatures will matter because that's gonna tell you what's gonna be exported, and it needs only to be persisted and ephemeral stuff, right? You should not be able to put in a signature a constraint.
Um, I mean, you may be able to. I don't see why not.
Because it doesn't make sense.
No, it doesn't make sense if the signature is going to be visible from Karuta, which is not necessarily true.
Wait, repeat that?
Like, you could have a signature that's only used internally in Sakura, in the Sakura code, and it makes sense to have a constraint in that signature, no?
I am extremely confused. A constraint is a predicate.
Well,
It's a
yes, you can.
declaration.
Well, yes, you can say this signature requires you to export a constraint with this name and this arity and this type or whatever.
Oh, wait. So you're proposing to introduce all of those things, all of those Sakura directives, such as persisted, constraint, ephemeral, as we do with modules inside signatures.
As we do with modules inside signatures. Well, we kinda need to, don't we?
That was not my plan at all. Because again, I was kind of thinking a signature in a Sakura file only matters to tell the application layer what is available. But now you're saying a signature will actually tell you what you need to define even on Sakura terms. So like stored procedures,
Hmm.
constraints.
Well, actually, do we need to go that far?
Well, I was not planning to, but I don't see a problem doing that, especially because signatures only exist at compile time anyway, and it's kind of more consistent.
Hmm.
Um, yeah, I'm okay with that. I'm just really bothered by having the schema directive because it's essentially
Well,
a bucket of compile time entities, and that is what a file is. So
that is what a module is actually. So if we're gonna have a module directive inside of Sakura, we don't need a schema directive. That's redundant.
that is not redundant
It is because
because
we can map modules to schemas if we need schemas when we send things to the disk.
okay, so put the meaning of a schema here. Hmm. Let's see how that looks like. So user, Q that, Q that, and then here. That's not. There we go. So your proposal is that a module name is the schema.
Yeah.
Is that a problem? Let me think. I don't think that's a problem. I don't see any problems with that. Um, yeah, I don't see any problems with that. Especially because in my original plan of making the file name the schema name, the modules names they would only matter for compile time, right?
Yeah.
They wouldn't be a thing in the. Wait, did I say bullshit? Wait. So in my original plan, the schema would be that. Ah no, but in any strategy, the name of the modules is still creating a new file, right? In our compilation strategy, in the when generating the
Um,
artifacts.
when generating the artifacts, yes, it is.
Yeah, so this would still be useful, but now you're putting more responsibility on it because now this is the schema name. Let's do the checklist. Does this allow us to have relations with the same name in different contexts? Yes. It keeps the signatures as having meaning because now that I have a module, now the signature can do something about it, and it unbinds the files from participating in the semantics.
I guess the only special treatment you have to do for all of this to make sense is at the very top level of the Sakura module, because it doesn't correspond to any real file, right? It's a logical concatenation. At that level, maybe we shouldn't allow predicates. Like we should only allow modules and signatures, maybe.
Oh, that's very interesting. That sounds like a preprocessor duty, but I don't see an easy way to do that because we are kind of relying on the same system for both Karuta and Sakura files on preprocessor. But the preprocessor could figure that shit out for us, and that's kind of faster than doing on the compiler because we're gonna already have spent time parsing more useless. Like it's wasteful, essentially. It's wasteful.
Hmm. Yeah, yeah, I agree. Preprocessor seems like an okay place for that.
Are we sorting the clauses on the preprocessor level? I think we are, aren't we?
We should be. We are, yes.
So what are we sorting? Let's take a look.
We're pushing any directives to be before any declarations, essentially.
Oh, but then that's perfect, right? Because you can just immediately, well, it's kind of meh because we're gonna still pre-process. We're not gonna blow up immediately. We're gonna still pre-process more stuff, but at least we don't have to go into the compiler to do that. We can actually go in the executor, grab the first clause, and if the first clause is not a directive, we blow up.
Um, that works. Actually, that does work, even after we do the
Yeah, it's
concatenation.
still wasteful because we're gonna pre-process the entire shiz, regardless if it's gonna be a valid program or not.
Hello, Nathan.
Hello. So the question is, can we introduce this notion in the preprocessor without fucking Karuta up?
That sounds kind of messy. Does the preprocessor have the file name as an argument?
Yes. No, wait. I don't know. I said before thinking. So this is the main function, right? Group clauses. It has, because the preprocessor, yeah, there's a file name in here.
Are we passing a file name to the... We are, right?
Oh, you cannot see the window here?
No, I can see the window. Like, we're passing that fake file name that we made up to this, right? And it has an
Uh,
SKR extension.
we are doing that, yes. Here.
Well, we can just check the extension. If it's SKR, then after sorting, if we don't have a...
We don't have to
Actually, that
wait for
doesn't quite.
sorting. No, we don't have to wait for sorting. If we know the file is a Sakura one, and we touch something that is not a directive, we blow up.
That doesn't work because the preprocessor is recursive.
I don't understand the problem. Could you elaborate?
Like, you can have something that's not a directive, which is inside of a module, and that should not blow up.
You got me there. I've been gotten. I think I've been gotten because yes, if you have something that is not a directive, but you are already inside of a directive, then that should be fine. Well, it depends on the directive, but theoretically it should be fine. Hmm. Now what? What do you say?
Well, I think I think sorting is one of the first things we do, right?
It's the last thing we do.
It's the last thing we do.
Can't we just do on the level of the filter map thing?
We remove comments.
Yeah.
That
Like,
sounds kind of hacky.
no. I'm not proposing to do the blow up in the remove comments. I'm not proposing that at all. I'm just saying that after remove comments and before doing the grouping, we are not recursive. Like, after this step and before this, we are not recursive yet.
We are not recursive yet.
This is still top level.
Clauses
Can't we
filter
just
match.
like pipe ch check for Sakura?
I don't see why not. Yeah, this should work.
It's still actually we can do it before even before doing the comments.
Yeah, sure.
Okay, so check for uh, what's the name of this? What the name of this function should be though?
Validate top level. I don't know.
What is the? Oh, it's file name. Okay, validate top level. I like that. Validate top level, and we need to put the file name in here. And let's make this function. Let's actually, yeah, let's make this function. Here. So this is going to be probably a recursive function. So validate, and that's not how you do it in OCaml. Right? I keep getting confused. This is an A case. Okay, so let's rec. Validate top level. We need to receive a file name, which is a string, which kind of makes it a little bit redundant. So let's actually.
We actually don't need the file name, Lemos, because we can say, okay, if the file extension is skr, then validate top level is, well, is a Sakura version of the function, which actually checks the thing. And if it's anything else, and we really only accept Karuta files other than Sakura for now, um,
I'm
but if it's
confused.
anything else, then validate top level is just identity.
Yeah, that's what I'm gonna do, but I needed an if, no?
It doesn't have to be inside of this function, though, is my point.
What do you recommend the if being in? Where?
Uh, okay, so inside of parser to compiler, we do the if, and then validate top level doesn't need to be recursive at all.
But parser to compiler is recursive.
But validate top level doesn't need to be.
No, it's because I was thinking on grabbing the list and iterating through, but we can just do a filter, I guess, that's fine.
Yeah, like.
So clauses.
Oh yeah, no. I mean validate top level. Like you can have a validate Sakura top level, I guess, function, and then it doesn't receive a file name. It just assumes it's a Sakura file, and it does the filter and whatever. And then inside of parser to compiler, you say, okay, validate top level is equal to, if it's a Sakura file, we call this validate top level Sakura, otherwise we call identity.
But it is recursive, this function. So we're gonna judge it wrong internally, no? When it's nested.
Mm. Right. This is the one that actually gets called inside of
Yeah,
itself.
yeah.
Yeah, that's kind of annoying.
Sure, but I think that's perfectly okay still to do it before. If then we do something about it, else clauses. Uh,
Well, one thing we could do is rename parser to compiler to something else. Make a new function called parser to compiler, which is not recursive, which calls the old version, but before doing that, it validates the top level.
before doing that, it calls the thing. You really want to put the if somewhere else? That's kind of surprising. Where that happens? So that happens in group? No, multi-mapper. Multi-mapper is the one that calls parser to compiler. I see. Why is that an end? Group clauses. Ah, because it's no, it's not mutually recursive. Ah, no, it is. It is mutually recursive. That's why that needed to be done. Wait, so your proposal is to change the name of this to something else.
Well, we would probably have to. Do we need to change the name of group clauses? I don't think so, right?
Yeah, but those two functions are mutually recursive. How are you gonna do the before step, keeping the mutual recursion?
No, no, no. Those two functions stay as they are, but I think one of them is the entry point that we call from the outside of this module, right?
Yes, it's the multi-mapper that calls parser to compiler that calls group clauses and vice, and then it continues.
You mean something else, like something outside of this in the executor, I think, right? Calls group clauses, which calls whatever, right?
Yes, yes, I think we are calling group clauses in the thing. Let's check. Oops. Um, Preprocessor group. Yeah, group clauses is being called here. And then group clauses uses the multi-mapper that uses the parser to compiler, and parser to compiler calls group clauses again.
Hmm.
Yeah, I understand that you want to remove the if from there, but I think that for now this is the quick win for us, so I'm fine. I can sleep on at night with that. Uh,
Actually, why do we have a preprocessor or a preprocess function in the executor?
because the executor is responsible for tying things up, which means that it does some. Well, actually, now that we removed the previous stuff that was here, we can just call it directly, I guess.
Um, okay, new proposal. Instead of calling group clauses, we make a function called run, like preprocessor.run. That's the canonical entry point. And we can call any non-recursive stuff in there, and then we call group clauses afterwards.
Sure. Um, so your proposal is to have a run function that
Yeah, that needs
receives
to
the
be a
same stuff as the group clauses.
yeah,
So
yeah, run needs to be
instance.
the last definition because it's gonna call group clauses.
That makes sense. That makes sense. Let run. Um, yeah, that. Um, let run, and it does these things. There's an equal here. Then we put the if in there. If is Sakura. Actually, I'm gonna grab everything. Even more. There we go. Then I'm gonna paste those in here. So this if is gonna actually live somewhere down here. So if it's not, then we just call group clauses on it with preprocessor and the clauses. But if it is not, well, if it is a Sakura file, then we have to do the filter thing that I was doing before. The filter thing will call validate top level. It will call validate top level. That should this should return an attempt. Yeah, yeah. And then yeah, let's just put a fail with for now. And I need to open the error thing. I'm not gonna open right now, so I'm just gonna do error dot. And let's actually put underscore in here. Then we do it like that. Um, then we say yeah, no, this makes perfect sense to me. So open error. We're gonna use the operators, so I can remove that. Then we say, hey, validate the top level to me. here's your file. No, here's your clauses. Then if that works. Oh,
I
but
think you need to.
if I no,
I think you
I
need to
should not
put
make this
a.
monadic though. I should not make this monadic at all because
I mean, you can because run itself needs to be monadic, right?
no, it's not. Run for the preprocessor is not monadic. We were wrapping uselessly. See?
Not really, because the preprocessor group clauses may not return.
It will
Well,
always return.
well, it can throw an exception. Actually, not really throw an exception. It can exit, I guess.
Yeah, that's why I'm saying we don't need an attempt. It's because we're gonna essentially just do the thingy, right? We're just
Well,
gonna explode.
well, yeah, we're just gonna explode.
Yeah. So, uh, but then
Exploding is nice, but you shouldn't look at explosions.
we just pipe that to here. There we have it. Probably I should do something like that. There we go. Then this guy, this guy. This is the one that should do the filter thing. So, uh, filter fun, fail with to do in if list is empty, list filter fun on clauses, then we just return the clauses. Else, um, we do logger simply error exit one. Okay, okay. So now let's think. What's the problem? Why is it mad?
Ah, it's because of parentheses, basically. Like the
Where?
semicolon is after the entire if.
The semicolon is here?
You need to put parentheses around the else branch.
Yeah, thank you. Okay, so we're gonna receive a thing, right? We're gonna receive a thing. Fortunately, we can just do function here and we start pattern matching. So what are the possible things that a parser clause can throw? Parser clause. This.
Or if it's a declaration or a query conjunction, we blow up. If it's a directive, we pass.
Exactly.
Which means we need to return true if it's not a declaration, I guess.
Yes. So content equals. So if it's a declaration, we're gonna return true, you said?
True.
True.
Because we're using a filter, so we need to return true to keep it, and then we're checking if it's
Let
not empty to
open
blow up.
AST in. Is this how you do it?
That should work, but I think you
Parser
also need to.
clause. No.
I think you
It's
also need to let
location.
open the location. Yeah.
Location. Can I remove this? Yes. No. Wait. Declaration is something something there. So maybe I do need parser clause. Yeah. Okay, I'm gonna do exhaustively because we are good boys, right? We deserve Christmas presents. So that's there. And
I think query conjunction should probably be true as well. We don't want to put a query at the top level of a Sakura file either.
oh, these are for the explosions. Sorry, I got it wrong. Okay, so what's gonna be the name of this thing? Uh,
Should explode.
is not directive. Okay, so here's another problem. We need the location. I'm so pissed right now. We need the location, man.
Well, you can put instead of putting the filter directly in the if, you can make a let binding for that.
Yeah. Yeah, no, you're right. But I was kind of thinking. I think I don't want to use filter. I want to use find. Do you have a find OPT? Yeah. I think I want a find OPT, man.
Okay.
In that case, we gonna do that. Oops.
Match.
There. And if we got none, we're gonna do
Return
that.
clauses.
But if you got a sum, then we're gonna grab the location. And then, oops, this can go away, and this can go away, and this can become error, and we can do say that. Beautiful. And then we're gonna say found known directive in a Sakura file. There you go. And this can also perfect. Um, perfect, perfect, perfect. This can die. And let's go through the completion errors. Okay, so now the preprocessor.
Lemos, try doing the thing. Try doing a dune build -w.
Uh, I understand what you're saying, but I really prefer doing manually instead of the watch mode. But I would try it the next time, okay?
Okay.
I really
I'm
prefer
kind of
having.
curious though. Any particular reason why?
Uh, underwhelming experience with F sharp
Well, but this is
back in the
not F
day.
sharp.
Yes, but I got but that's what we called trauma. Um, wow, that
Oh
didn't
yeah, you
work.
need to put an OK after that, right?
Ah, yeah, I'm gonna need
Oh no,
to.
actually, I think you can use a map here, an error map. Double it.
Preprocessor. Annoying. Annoying. I think I changed my mind. Uh,
Preprocess needs to take the file name as an argument, I think.
really? Yes, it does. Sakura. And then. Man, there must be a point-free version of that. Like it's very clear in my head that it must exist, but let's not do that. Um, um,
Actually,
this can fail? No, he cannot fail. Yeah, we cannot. We need the other stuff. We need more stuff. Now that we put this argument here, we need more. Actually, do we?
no, you can just
Let's.
rename Sakura file name to file path.
Yeah, and then this becomes a function. Receives that. Receives that. Yeah, but it's still wrong. This returns an attempt, yeah, at least attempt. So this should be fine. No?
Ah, it's because that thing is not actually monadic.
Yeah, that makes sense. Okay, so where else are we using this shit? Here we go. Wait, this preprocessor receives a full preprocessor. So wait, there's something really wrong in here. Our original preprocessor function received a preprocessor, not this, actually. This is not monadic. Why are we doing error map in here? Yeah, this is wrong. We should not do that. We should do error map preprocessed, and we should actually use a given preprocessor instead. Eh,
But but then preprocess is just preprocessor.run, no?
I think I'm just being silly. I think this is just this. Yeah. There's something really wrong though. So what is going on with this not being used? What's up with that? Ah, it's because this is not monadic anymore? Maybe. Oh no, but this needs to be monadic, right? Because, yeah,
No, you need to call error.map.
no. No, 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 no.
And this is not monadic.
What is not monadic? Run?
Error.map is not monadic.
What do you mean? Look at the type.
Because it's just functorial, it's not monadic.
Ah, so then you need to remove that. That's what you're saying. Unbound record field dependencies. What is this returning? Wait, what? Man, don't build. Um, that was silly, but okay. Yeah, no, that works. Okay, so what did we change? We made sure. I'm gonna finish the recording because we are here for like ages.